Hello everyone, welcome to today's webinar, Recovery Goes Beyond the Visual, Experience Remote Digital Tower and UTM Concepts. Before we get started, I'd like to go over a few items so you know how to participate into today's event. You may have joined the presentation listening using your computer speaker system by default. If you would prefer to join over the telephone, just select phone call in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. It is my pleasure to introduce you to our moderator today, Haiyang Jiang, Director of Asia Pacific Affairs for Canso. Haiyang, I hand it over to you.
Hello everyone, and welcome to the webinar sponsored by Frequentis entitled Recovery Goes Beyond the Visual, Experience Remote Towers and UTM Concepts. I'm Haiyang, Canso's Asia Pacific Director, and it's my pleasure to welcome all of you to this webinar. Thank you for joining us for what promises to be a very interesting workshop, where Frequentis ATM experts will discuss recent digital tower deployments in remote locations, the installation of safe and secure ATM-grade network solutions for areas with challenging internet connectivity, and new operational concepts combining the management of manned and unmanned airspace. We will have two sessions comprising two presenters per session for each topic. So for the first session on network solutions for remote towers at very remote locations, we have Matthias Gerlich and Peter Gridling. For the second session on the topic combining UTM and ATM for future growth to enable professional drone services, we have Gunther Graf and Roman Stickler. So at the end of both sessions, we will have a 20-minute question and answer session. So if you have questions during the course of the presentations during both sessions, please type them down in the question panel. So let's start with the first topic on network solutions for remote towers at very remote locations. This session covers the advanced network management solutions that enable the establishment of remote tower services at locations with limited network infrastructure. Now, in this session, we will learn how to use non-fiber network technologies like SATCOM or microwave connections to connect remote airports to remote tower centers. The first speaker for this session is Mr. Matthias Gerlich. He's an ATM network expert and Senior Sales Director, ATM Civil at Frequentis AG. Matthias is a long-term veteran of the network comms industry. He worked in various positions, including 4 years in the United States as Business Development and Sales Director for a VSAT vendor. Matthias joined Frequentis in 2014 as a Senior Sales Director, ATM Civil, with a focus on ATM-grade networks. And our second speaker for this session is Mr. Peter Gridling. Peter is a digital tower expert and Vice President Sales at the Frequentis DFS Aerosense. He graduated with an engineer's degree in computer science and has a strong background in camera and image recognition technology, including forming a startup company in this area. Peter joined Frequentis in 2016 to support the digital tower team and is now Vice President Sales for Frequentis DFS Aerosense. So let's start with Matthias. The floor is yours, Matthias. Over to you.
Thank you very much, Haiyang, for the kind introduction. As always, pleasure working with you. What we want to do today is, as you mentioned earlier already, we will have an overview about various I think, exciting new opportunities in the field of communication, especially in areas where we are lacking or suffering connectivity via fiber optic connections due to geographical issues, such as in the Asia Pacific region, where we have a lot of islands, a lot of very difficult terrain to access, to pull cables in there, but also in areas such as Africa, Latin America, Central America, and the Caribbean, where we're relying on a lot of times on VSAT technologies, very small aperture terminals that are connecting to specific satellite type. But now we have, due to new launches of new satellite connectivity capabilities, we have the opportunity now to even cover these regions in different ways, which might be in the future more cost effective and also helpful for the ATM industry in regards to throughputs and associated cost with that. So what we want to focus today on is the VSAT part more than the microwave part, which is a point-to-point connectivity that has also advantages and some disadvantages, of course. We want to look what do we need if we want to enable these VSAT technologies, because they have also certain issues. Therefore, we are providing tools within Frequentis to overcome these hurdles and to enable really ATM operations within these networks. And very key part here is the performance itself, but also the correlation between the performance of the application and then the visualization of it. That means the view, so people can really figure out in a very easy way if their specific services are performing accordingly to the requirements of the application. And then what is the impact, of course, on safety and security when it comes to transmitting such applications over these new technologies. So next slide, please. So the first thing that we want to have a quick look into is the VSAT technologies in regards to the geo constellation. That means satellites that are located over the equator in about 36,000 kilometers. These are geostationary. That means fixed satellites in a fixed orbital position, where you're normally pointing your larger antennas towards with certain electronics, with its advantages, disadvantages. But also one thing that is very, as I said earlier already, an exciting opportunity, I believe, in the near future would be the LEO constellations. There is companies, for example, as Starlink, that has just launched the first thousands of satellites that are in a much lower orbital position. Again, the advantage there is that we have less latency, but also can ensure higher throughputs, but it also has some downfalls that I want to talk about in a minute. Then what we have done in Frequentis within our portfolio that is called Vital Sphere and focuses really on ATM customers only, where we see that there's a lack in commercial off-the-shelf products to do these measurements to ensure a certain performance due to not having the capability within these COTS products to really do the performance measurements of a certain applications or resolve issues within an application itself. So what our focus is within Frequentis in regards to the measurement is the end-to-end performance to ensure, for example, when it comes to operational voice, and we are working in an offset mode or climax mode to enable functionalities or have functionalities incorporated that resolve, for example, the echo issues, even over challenging links, such as, for example, VSAT in combination with terrestrial links, where we have various variations in the runtime of the signal, and normally that causes echo issues on the headset of the pilot, but also on the headset of the controller. So this is what we have in the tool set to resolve such issues, but the same applies, of course, to surveillance data, to remote digital tower, as we will see later. They have certain challenges when it comes to video transmissions. We have to have really high throughputs that we are not used to in the industry in previous years. So we need to have pipes or links that enable such applications. And then the next thing would be the network management itself. And the network management has several elements. One is, of course, the full-blown stack of managing networks, from tools as the fault management, the configuration management, performance management, and so forth, but also the monitoring capabilities itself as a standalone solution to measure certain services, such as operational voice, such as video streams, such as surveillance streams, that go hand in hand. So we have also built a solution that is, I would consider, very modular. So it does not need necessarily to have all the functionalities of network management tools out of one procurement, but you can really build up a solution that goes modular from a monitoring capability up to the really full-blown umbrella management functionality. And last but not least, again, ensuring safety and security, that these services run in the way they have to run. And what we do with Frequentis when we build these solutions is, of course, then and one of the ultimate goals is in higher availability, but not only the availability itself, that wouldn't help, but also the performance characteristics matching the service that is running over a certain network. Next slide, please. So looking into these GEO and LEO satellite constellations, so on the left-hand side, we have that typical GEO satellite setup, where we have in these areas, if we are in Asia, in in Africa, or in South America, Central America, Caribbean, certain coverages via certain vendors that provide certain frequency bands, such as C-band, Ku-band, with its advantages, disadvantages, smaller dishes, smaller transceivers, but for example, less availability. On the other hand, in Asia, normally we're using C-band constellations, which have a very large coverage zone. That means we can, in one network, in one footprint, incorporate normally all the stations that are part of the network. But again, that also causes certain issues in regards of antenna sizes, in regards to transceivers, power consumptions. So for example, if we have to build up such systems in very remote locations, we have to transport the whole gear there. We have to ensure we have appropriate power sources that can support the antenna system in regards to power requirements. So for example, if we have a remote location where we would have to use diesel and diesel generators, an issue would be how to get the diesel there, what are the power consumptions, then we have the whole setup of the system, we need to make sure we align it correctly, and then of course there's cost associated to that. Cost in regards to bandwidths, megahertz that we have to procure to enable certain applications from that side. The other thing is, of course, we are talking about a distance of 36,000 kilometers from the ground terminal, ground terminal towards the satellite. That causes delay times. If we're talking about round trip times of 500 milliseconds, can even add more depending on the processing on the ground terminals and the applications again. So there is advantages and disadvantages. One advantage definitely is that we can ensure a fairly high availability there, and depending on how we set it up in a shared service or in a dedicated configuration, that we have certain service level parameters matched, that we can ensure a service classes to provide the best performance for certain applications. On the other hand, as seen on the right hand side, we have these LEO constellations now, low Earth orbit up to 2,000 kilometers. It also depends again which provider you're choosing there. And they call that mega constellations, where you have really a lot of satellites in space that you normally have a certain coverage there. You also have, of course, a much lower latency because of the distance traveling of the light from the ground to the satellite and back from the satellite, the amplification down to the Earth terminal. We can ensure lower latencies there from 20 to 40 milliseconds. And of course, that is advantageous for certain applications, especially when it comes, for example, to operational voice or, or video applications. It is not that critical if we're talking about certain applications that are not really time critical. Next slide, please. So looking into these terminals and the constellations, as you can see on the picture on the left-hand button, this is very high coverage, and it's just the start of it. They have about 12,000 satellites already launched, approved for stage number 1. So this is that will ensure a worldwide coverage. What is also a big benefit here, of course, is that we can cover regions which we are not capable because of the surface of the Earth and the constellation and the setup of a geostationary satellite, where we cannot cover really the pole areas. That means if we have flights going over the North Pole, for example, then it's very difficult via satellite constellations in a geostationary setup to have coverage there from a ground perspective, but also from a satellite perspective. Even if we're changing feed systems from the bottom to the top to change the look angle towards the satellites, it's almost impossible to have up to a certain level in the north coverage. So with these new low orbit satellites, we can even cover that area and get communication into very far northern and southern areas, which is of course again a big advantage. The other big advantage that I see is the easy setup. The easy setup, that is easy pointing, small terminals, less power consumptions, smaller dishes. But again, the impact, of course, is that with these smaller dishes, if we have areas where we have high rain fade, where we have rain seasons, such as in Asia, we don't really know today how much throughput will be ensured, what is the availability. Normally in these satellite networks, depending on how we set them up, geostationary, for the geostationary in a redundant way, non-redundant way, different satellites in parallel, we get a 99.5, 99.0 availability. That's normally very high because we have also the sun outages and other issues. So with these new low orbit constellations, it is not really sure how much we get on in regards to availability. Nevertheless, I think we have to use them in the future as well for certain tasks, if it is as a backup system, if it is for disaster recovery, or maybe even in some areas where we have really not the issue of, for example, rain season, where we have very less environmental issues or lesser environmental issues in regards to clouds, rain, snow, and so forth. Maybe can even use them in a much different way. What needs to be done, of course, is with these satellites that, as you can see, also ensure a higher throughput from 50 to about 150 megabits. There is not really KPIs and service classes implemented yet. So what we do or can do in Frequentis, and what we're enabling our customers, is we can, via tools that we have in our VitalSphere portfolio, ensure that we have service classes on site available on a per site per service configuration capability. So that said, even though the network itself will not provide it today, from a Frequentis point of view, with our tools that we're implementing, we can ensure KPIs and SLAs. Next slide, please. So how do we do that? If we look into these two levels we have on the upper level, the application view, where you have all your services connected with each other. That means you have your voice services, surveillance services, data services. In your environment, this is what you manage, this is what you need to get your daily job done. On the lower button, we have the physical networks. That can be, of course, terrestrial networks, that can be microwave networks, that can be satellite networks. Previously or up to today, it's normally, when I look into the region and look into these international networks, it's geostationary, very little iridium phones and so forth, maybe, as I said earlier, for backup purposes. But in the future, maybe also some low orbit satellites and networks that we could utilize. Yeah. The issue again is the mid layer. It's the combination of the network plus the network networking equipment. That means the routers, and so forth, the interfaces that we need to provide to connect the applications, such as, for example, for VHF radios, for radars. Some of them, they're still using legacy equipment. Not everything is towards IP today, so we need to also ensure that we have smooth migration passes. Nonetheless, we want to use these new constellations. We want to ensure higher throughputs, more availability in certain ways, and to ensure disaster recovery solutions are also in place if some, for example, disaster hits us. And what we are doing now within Frequentis is we are covering that mid layer. So we are not only providing interface cards to connect applications physically, but we are taking care on resolving issues. That is, for example, in the mid layer, the intelligence that we are measuring these links from the application, from the center towards the remote side on a permanent basis. We look into performance characteristics. That means, for example, in voice, we have certain issues in regards to jitter, to delay, to packet loss. So we are making sure we are on track on the path. That means that the path that we are recommending the application, network 1, network 2, network 3, fulfills the characteristics. And then on top of that, we're resolving the issue. That means if we, for example, have on a path that works fine, doesn't mean that the application works correctly. That means if we have, for example, as I mentioned earlier, for voice climax mode, offset mode also known, where we are addressing multiple radios but facing issues with runtime variations, that we are adjusting to that. So we're measuring permanently these passes if the link is correctly, but we are also measuring if we run into performance issues in regards to, for example, echo. So how do we do that? Next one, please, Helen. Therefore, we are using tools within the VitalSphere portfolio to configure on a per site, per service basis characteristics, performance characteristics. So for example, for air-ground, for ground-ground surveillance, remote digital tower, and they all are very different. So that means, for example, a ground-ground call has maybe other performance characteristics than a VHF call. And then we have multiple, for example, VHF sites on remote locations for main, standby, multiple frequencies. But the issue starts really when we're running in bandwidth limitations, in unpredictable links, how to handle all these applications on a remote location, that it connects correctly again to the VCS and the controller gets the best information, the best voice quality, the best surveillance information on his screen. We need to manage certain service classes, and that means we are introducing service level management. That means every application gets its own treatment. Not everything runs into certain queues that are available by the telco provider, and we're measuring these links permanently. So we're ensuring that the link quality fulfills the configured service requirements, and if not, then we are taking action and looking for alternative passes that are also configured. Next one, please. So for example, from a configuration standpoint, it would look like that. We would have operational services, that these are the ones on the right, on the left-hand side. For example, air, ground, ground, ground. And we are telling then how we're going to measure on a, for example, per call basis. We are telling certain characteristics that have to be fulfilled. We are not want to exceed certain delay and jitter parameters. We do not want to have a higher packet loss than a certain packet loss that we have configured. And we might want to also measure mean opinion score for the voice call, and the call shall be compliant to ED 137, at the moment B, compliances. Then we tell the application that can be a specific frequency, and not all frequencies on a remote site have to have the same characteristics, which network the call is allowed to use. So for example, here we would have 3 networks available, 2 MPLS networks and a third network, which could be VSAT. And we're telling that call, it can use all 3 networks. The primary one is the MPLS1, secondary is the MPLS2, third one is the VSAT network. And whatever path fits best, it runs over that path, that specific application. And if the pass fails, it looks for the alternative one. That can be VSAT or it can be the MPLS2. When the first pass is available again, it switches back automatically to the first pass to get, for example, more bandwidth freed up again on the VSAT link, because the VSAT link might be only the backup network, which is very cost intense, and we do not want to have then applications that switch to an alternative pass allocating bandwidth there permanently, because then we would have to do also different bandwidth consumptions. Different bandwidth consumption would most likely then result in a to ensure a certain availability would result in a more bandwidth requirements, more hertz that would have to be procured. That means higher cost. And then we could go down in the configurations. We would have video with certain performance characteristics, also allowed to use all three networks, down to best effort or admin traffic that runs over the same network. And I'm not talking about these different networks. For us, it's really seen as one bandwidth pool that consists of multiple networks, and we are ensuring that all the applications are running via these different passes or links in the network with the characteristics we have configured. And so, for example, the admin traffic, that could be email exchange, that can be SAP application, something like that, would only be allowed to use MPLS1. In the event that the MPLS1 network breaks, then it could not use definitely the VSAT network. There is no need then to say we're allocating with, for example, SAP database updates and VSAT link. Yeah, that is not necessary. Might want an hour or two where we really cannot use that specific application, but on the other hand, we're saving a lot of cost on the VSAT link, and we're not allocating that link and the bandwidth that is available there for such applications that are not real time and they are not increasing our safety and security. So next slide, please. So from a perspective, and Peter will later show you in a demo some examples how that works is, on the left-hand side, you would have a traditional network where you have your routers on the left, your router on the right, you have your switches and applications connected, and you start your application running, and you figure out after a certain amount of time that there is an impairment. That could be a packet loss. Yeah? The packet loss not necessarily would not tell the application, hey, guess what, you need to switch, but it would degrade the for example, in video, the video quality. As you know from home, when you have, for example, high rain fade and you have your dish on the roof, or you have here in Europe, you have snow, and the dish gets a little bit covered with snow, that the performance suddenly goes down. That means you have a lot of pixels, and you can still see, and maybe you can even hear the sound, but it is not a really good quality anymore. Anyhow, the link would not change. It would still stay there because the routers would say it's still good enough. I'm receiving the other side. There's no need for me to really switch to an alternative pass. So what we are doing is, when we see, as configured earlier in the slide, we have configured a certain packet loss, for example, for video, then we would switch immediately to an alternative pass, even though the first link is still there, it is working. We would switch video because the video characteristics are not fit anymore. We would maybe still keep other applications which performance characteristics are fulfilled in the first link on the traditional, let's say on the left-hand side network, but certain applications that are suffering now, like video, when you're observing a runway for obstacles, would definitely not work anymore. And then we're switching there the pass. We keep others there. If the primary pass is back again, we're switching back to that primary pass. Okay, next slide, please. This is just a quick example about the commercial IP WAN experience on the left-hand side, and an ATM grade experience, how we're setting that up today for our customers with remote digital tower deployments. So on the left-hand side, if you see the two circles that are made on the right-hand side, there is an obstacle on the runway, a car, and you see already an aircraft on the right-hand corner on the right picture. There's an aircraft in taxi approaching the runway. But from the video quality perspective, if you imagine you have a remote digital tower controller sitting a couple of 100 kilometers away, I would not really rely on that picture and make a decision to say the aircraft is all good and can later have a takeoff there. So what we're doing is we're switching that link towards that, what I mentioned, alternative path, and we call that a brownout detection. Brownout detection is something that comes from the electricity companies from the old days when you had that orange light in your room. It was still there, light was still there. It was not really bright anymore, but it was kind of orangey already. And what we're doing is when we see that degradation, we are switching the path even it's there. That means we are avoiding really a blackout that causes then, of course, a lot of other trouble and issues. Next slide, please. So from a configuration standpoint, and that is the first part of what I wanted to introduce, is we're collecting a lot of information. We're setting up a lot of passes, routes, SLAs, KPIs within that network to match the performance characteristics for these applications as ground-ground, air-ground, video, radar. That means surveillance, can also be ADS-B. We are increasing with that then the situational awareness, because everything that we are collecting within the network, we are transferring later into monitoring tools. So that means everything that you have configured, you can later measure, and measurements translate then into visualization. That means we have a situational awareness that helps, of course, then the operator to determine earlier what's going on in the network. Is there any error? Is there any issues on the network? It helps then later with the troubleshooting of the links. That means also increasing the availability, having a better situational awareness, and be able to react faster to errors that occur. That incorporates the brownout detection as mentioned earlier. Act before failure, not waiting for a link to really break, but switching the link or the application to an alternative path before the controller gets a black screen, for example, or the video gets very, very blurry, or the voice call introduces too much echo. So then we are taking these alternative passes. We're also measuring, as I mentioned earlier, various passes, for example, the voice, the ground-ground, the ground-air-ground, and we're measuring also mean opinion scores there. So that means we want to see what is the voice quality. Is the voice quality according to the guidelines? Do we have echo on the link? And then we're taking measurements. Out of the measurements, we're taking actions. On the right-hand side again, by using all these tools, we can then, of course, increase, first of all, the availability of the application, because we're reacting faster, we're measuring these links, we know the characteristics. Do we have to go to the right path, to the left path? That means the application will have a higher availability. Then that results at the end of the day in bandwidth savings, because now we can model the availability completely different. In the old days, when you had a terrestrial network and a VSAT network as a backup network, normally you calculated the bandwidth consumption equally for both networks. That means you measure and you calculate how many VHF calls do I have? How much surveillance data do I need to transfer over the network? And what other applications do I have? For example, AMHS. Then you had to ensure, of course, that all these frequencies, especially for air-ground communication, all these frequencies are permanently available. That means there was not a way where you could say, if my primary network fails, we're switching everything to the alternative path. And on the alternative path, we're only enabling a frequency 1 or 2, unless you did it manually by disconnecting or connecting cables to it. But if you wanted to ensure that all applications work on the backup path as well, your bandwidth calculation would have been amount of voice calls multiplied by a certain throughput. Availability needs to be 100%. You had to have certain peak times, and that resulted all in an amount of bandwidth, depending on modulations and so forth, that you would have to procure from the operator. And that gets expensive. Yeah, and this is what we can do now very differently, because we can ensure certain applications only using certain networks. That means we can reduce the overall bandwidth amount by every application uses the same infrastructure, and that, of course, is a huge bandwidth saving. Yeah, and this is very, very important in regions such as Asia, in Africa, and so forth, where we are relying a lot on satellite connections. So that all, and this is the next part of the presentation, then results in a very high operational experience, where we're giving now the visual pass, the visual information to the network operator to see on one screen in one tool that all applications are fulfilling the requirements. So next slide, please. So when we look into these network management systems, and again, the network management system has two elements in our portfolio. We have, first of all, the whole measurement pass. So you can really use certain tools to measure certain applications. If you, for example, interested in, we have a voice network, we want to transfer voice, but the quality is not good enough, then we have the measurement tools for voice with the associated monitoring tools. But of course, at the end level, we have a full-blown umbrella network management system, and that incorporates all the elements, not only the monitoring side, but also the fault management, the configuration management, performance management, security management, and so forth, inventory management, to allow all tasks. But if you already have a network management in place, such as, for example, an OpenView, a WhatsApp Gold, then we can incorporate certain tools that you can still use your current platform, but enable it to make it more ATM grade and to have these service measurements in place. So when we look onto the applications, for example, the VCS, the air-ground radio, surveillance, and so forth, then there's not really a lot of collaboration between these systems, and none of them really does an service, ATM service-based measurement. So what you measure normally is you measure your throughputs, your packets loss, your jitter, your utilization of the links. You do a device monitoring and so forth. You can do configurations on them, but that doesn't really tell you if the performance of the links are sufficient for a certain application. So next slide, please. So what we call it now, this is the advanced NMS, and I mentioned that earlier already. We're increasing, first of all, the operational awareness. So measuring everything and having all these setups done earlier, as mentioned before, we are transferring now that these information into that monitoring network management tool. And that again allows then the operator to react much faster. Yeah, so he can measure a lot of different things. We have also tools incorporated where we make it predictable. So we see certain changes, for example, on a VSAT modem. You could see and measure, for example, the power levels. If they're increasing, that means we have maybe a blockage because due to clouds. We're changing forward error corrections. We're going from a different modulation from 3/4 to 1/2. That means we're reducing bandwidths because the modem is already, or the outdoor unit equipment on a VSAT link is also already in saturation. What it does normally, it decreases the amount of throughput that he has to send over that link. That means now bandwidth is not sufficient anymore for all applications, and that's why it's even more important on such links than to have tools incorporated, as I mentioned earlier, with the net broker to measure these links out. And that results again having predictability as well in a higher amount of safety. Yeah? So we are not reacting, we are acting before a failure occurs, and we're measuring devices. So next slide, please. So from an overall overview, on the very bottom, you would have the monitored elements for the various services. So you set up your services on a per site, per service basis, as you have seen before in the tool where I have configured air ground services, ground services, surveillance services, but also new services such as, for example, SWIM can be incorporated, will be a part. There will be data exchange between various ANSPs. So you set up the classes that you need for that service to ensure it fulfills the requirement. Then there are certain modules, as I mentioned earlier. So you get certain tools from us to enable these services. That is basically just software. And then you have your own monitoring tools. And last but not least, on the very top level, then there is the full-blown network management system, where you have certain databases. They are normally geo-redundant, to ensure also again a very high availability with all the tools then to configure them and certain dashboards and reporting analytics to see really what's going on that certain path. Is it fulfilling the requirements and so forth? Next one, please. As mentioned earlier, so from the setup in regards to your NOCs, there is no really limitations in regards to how you set that up in regards to distance. For example, from NOC 1 to NOC number 2, that applies of course also to the SOC, because a lot of information, that means to the Security Operations Center, a lot of information that you receive today can also be transferred and be very useful there. That means, for example, we have an issue on a VHF link. The network operator would now look for the technical root cause and would see, for example, a router failed or a transceiver on a VSAT link failed. But also we can parallel forward that information and apply it to security measurements again, to be sure, for example, we are not getting attacked by an intruder, who wants to jam or wants to break our VHF links. So we are not only transferring the information into a NOC, it can be also transferred into the SOC to start in parallel analysis. From the setup, there will be always a clustering on the databases in each network management center. That means we are updating these databases permanently, so they're always on the latest, on the same level. That is very important when it comes, for example, to reconfigurations, that we're not using misconfigurations there. But also if we have, for example, an outage in one or the other NOC and there is an update already on the databases, we're distributing that information to the other databases again, that we have not only NOC 1 and NOC 2 on the same level, but all databases in both NOCs are permanently updated. From a remote perspective, there's also various capabilities that help us to ensure bandwidth savings, like local storage. When we, for example, collect information that are not necessarily real-time but important, then we can store that information and not jamming the network always, or utilizing the networks always in a real-time path, which is possible. But if it's not necessary, we can store and then, for example, overnight, where these networks are normally freed up, do updates of the databases with the information that we have stored on the remote ends. So that again helps us to reduce bandwidths. Next slide, please. So that's a typical example, and I always try to explain that very simple. So that would be how such service passes look like that we implement for our clients. We have a typical setup of for a VHF service, for a radio frequency, where we're using 3 networks, MPLS, TDM, VSAT on the very low bottom. And we are monitoring now all devices from the VCS up to the radio to see if the performance characteristics are met. Is there echo on the call? Do we have to put certain measurements in to resolve the echo on it and so forth? But we are also looking, are the passes okay? So we have, for example, on the left-hand side, the main standby VCS, they're okay. We have the net broker, that's our measurement tool within the VitalSphere portfolio. Main standby, that's also configured redundant, it's also okay. We have the routers, we have the WANs, they're okay, but we see on WAN number 3 on the VSAT link, we have certain issues. So only WAN 2, WAN 3, and WAN 1 are available. We have then all the way down the path to the radios. We have the TX, RX, let's say frequency 1, 2, and 3 there. 2 is not working, but that's not necessarily an operational issue because we still have alternative frequencies there. It's just an example again. So on the overall status, it will tell me it's orange on the left-hand side. So we're measuring, are they working? Is the quality okay? Yes, that's okay. And we're working on frequency 123.5. So what we are also doing is now on a regular network management system, you would see all the devices are green or they are red. You would maybe see that the utilization works. Utilization is on a certain level. We have a certain jitter, packet loss, and so forth. But what you would not see is if the call reaches the pilot. So when the operator pushes PTT, does the pilot really hear it? Because what could be that all your devices from a network management perspective, they're showing up green, but you're on a wrong frequency. So in that event, we're also measuring, are we on the right frequency? And is maybe the VHF radio tuned to a wrong frequency? So we would then get the information from the VHF radio, not closing on an air loop. Hey, there's a wrong frequency. The pilot will not be able to hear you. And then the controller can act accordingly, the network operator can act accordingly and do the necessary changes there. From a regular network management perspective, you would never see that. You would just see everything is fine. For me, that's no issue. And the voice call would never arrive on the headset of the pilot. If you do not have these measurements in place, you would never figure out in the very beginning where is the issue really. Next slide, please. So again, I have to keep that now very short. As mentioned earlier, that's basically my wrap up. We're measuring, if you see on the very left, on the very bottom, from the center to the sides, we're measuring all passes through, and we're taking the information to make the application behave the way it needs to, or actually we make it the way around, the network behave as the application needs it. And then we're transferring that information into multiple visualization tools from a monitoring perspective for the various streams. That is also implemented various capabilities for surveillance, for remote digital tower, for voice. So it's not only related to voice. You can have certain setup in regards to measurements. And then we transfer that into certain tools. I just have a quick screenshot, but I'm again very happy then to give you at a later stage more insights and more details about that. So next slide, please. So here you would see, for example, and I'm sorry, that's of course just a screenshot there. On the right-hand side, there is the various services for voice, for data, could be surveillance, could be also administrative data. Connecting these various sites, they give you a certain status, for example, a brown for a brownout, a green, the pass is okay. But again, this is the end-to-end pass. It is not the link. So people mixing it up a lot of times. If the link is sufficient in regards to, for example, bandwidths, we are measuring the service, not the link itself. And then you can see on these different passes, on these different connections, for example, from a site to another site, we're using different passes because, as I mentioned earlier, the characteristics for that particular application is not met anymore. And you get that on the screens, and you can see immediately my VHF service 1, 2, and 3 are correct. We have a little issue on the administrative service, but this is taking only the measurements for example, the utilization into consideration to have the end-to-end service view. So that's a very, very big difference here. Next slide, please. So what we are doing is we are creating, and this is definitely a very important measure or a very important thing, a higher situational awareness. You can immediately figure out what application on which pass is not working correctly anymore. That allows a lot of things like the troubleshooting, the resolving of the issue, but also the switching towards alternative passes to ensure the continuity of the service. We're acting before failure. The measurement tools and the associated bandwidth calculations and bandwidth requirements, they reduce in significant bandwidth savings. They can be very, very, very huge and of course save cost by not suffering safety and security. And that was the last part, the safe and resilient solution that still has of course the most priority. But again, we are all facing budget issues and cost is always a big driver, but again, not suffering on safety and security. So next slide, please. And so what we are doing is with these new constellations that require, as I said earlier, these LEO constellations require more measurements, more attention, as we maybe have in an MPLS network today. With the tools we provide, we can enable these links that the applications are working over it in a combination. And this is also something up to discussion is how do we use such constellations, LEO versus GEO versus terrestrial infrastructure? Can they work as backup solutions? Do they have to be primary, secondary? Is it a disaster recovery solutions? But definitely it will help us to increase the availability. With the tools, as mentioned earlier, using also such new constellations, which are much cheaper in price in comparison to geostationary satellites, we will reduce the cost again. And that all relates then again to increasing the performance of the overall network by measuring these links and bringing it into one combined, let's say, network where no application needs to suffer. So that was basically it. But maybe the last thing again, the measurement, and this is very important, then results into a graphical tools visualization that you get a really end-to-end view of your applications and of your network and the performance of it. Thank you.
Yeah, Matthias, thank you for the introduction. My name is Peter Kriedling, and you see me here sending out of the aviation studio in Frequentis headquarters in Vienna. Just a formality at the beginning, I don't have slides, so I would like to ask you to make my video as large as possible because I will do a live demo with the system you see here behind me. And what you see here is the typical remote tower system. I will be later introduce into the network capabilities, but just as a small recap what our remote tower solution is about and what it can do, I will have a short summary for all of you who haven't attended a webinar with me in the past. So what you see here behind me is a typical remote tower configuration. So you have typically a panoramic screen showing either 360 degrees or a portion of the panoramic view of the controller to reproduce the out of the window view. The out of the window view is extended by different augmented reality features, meaning showing data and markings directly in the field of view of the air traffic controller, which reduces the head down time and increases safety. I would like to show you an example how that looks like. So when we have a closer look here on the left side, on the left screen, then you see here in this area different overlays, starting with the compass rose at the very top of the screen, but then also showing weather data directly as an overlay in the field of view of the controller, and also dynamic overlays like those eyes, would I say, the yellow and the green eye, which is showing the direction of the panted zoom cameras. And what you also see here is some surveillance overlays. So if you have surveillance in place, then we are using the position data of the surveillance, placing or matching the surveillance position with the position in the image, and then showing information of this flight directly beside the specific aircraft. So, and all those features have one target, basically to increase the safety compared to a mortar and brick tower, and of course to reduce the workload for the air traffic controller. And again, reducing the workload is again an increase of safety. Besides those overlay features, we have also the possibility to present or to add additional safety features which have not been possible in the past. And one of those safety features I would like to show you in a different scenario. So I switch over this scenario to our installation at Jersey Airport. And what you can see here on this taxiway going on is that we have a virtual stop bar then. So the system includes an object detection engine which automatically detects objects by the camera feeds. And now when this detected aircraft moves over the virtual stop bar without permission, then immediately there is an alarm. So the aircraft is marked as red, and of course also the runway is marked in a red color, so that the air traffic controller is warned that there now a runway incursion has happened. And I would to emphasize that this feature is solely without any surveillance in place at this airport. So this feature provides an additional possibility, an additional safety feature for very, very small airports, which typically don't have surveillance in place. But as you have seen, the topic is always that at the end, you're fully reliable on the video information. So regardless if it's just the out of the window view or if it's the use of these additional safety features, all of them are relying on the video transmission. And this is the reason why the video transmission in a remote tower environment is so important, because if you are losing the video, then you basically are losing the situational awareness, and you're losing also all the safety features which are in place in such an environment. And a problem which we faced in the past was that often at very remote locations, we maybe don't have the network conditions which are or which should be in place for a remote tower environment. This could be lacking bandwidth, or this could be also a network connectivity which is not 100% stable. And in combination, that video transmission needs a very high quality network with high bandwidth, but also a very stable network. Of course, that is the perfect combination. And that was the case why in the past, often for very remote location, which would be the perfect fit for remote tower applications, those airports have not been considered to be connected to a remote tower center because of the lacking network quality. And basically, since Frequentis has a very long history of implementing network solutions exactly facing this problem in the field of voice communication and other data communication, we now have extended that concept to video transmission, so that in the future we can also provide safe video transmission in networks which are not 100% reliable. And as Matthias has spoken before, or has told you before, we have now the possibility, new possibilities with the low orbit satellite connections. But all of those systems have one disadvantage. The performance parameters and the quality parameters, they are varying. That's the principle of those satellite connections. So for low orbit satellite, that will never change by technology progress. So at some point, the performance will always vary in such environment. And this is not an issue at all if you can deal with that situation. And that's exactly why we have the perfect solution with NetBroker managing such networks. And I would like to show you how we are dealing with that. Therefore, I will show you a scenario with a multi-remote tower. So what you see now behind me is a typical multi-remote tower setup. So Frequentis is researching that topic for a very long time now, and we expect in Europe to have in 2 to 3 years multi-remote tower installations in place. What does multi-remote tower application means? That means that one single air traffic controller for very small airports can handle multiple airports. So a typical example you see behind me, we have here in the upper part our installation in Akureyri. This is a very, very remote location at the very northern part of Iceland. And we have here, for example, in the lower part, Saarbrücken Airport. And the air traffic controller sees both airports at the same time, and he is able, with the tools provided by Frequentis, to handle both airports at the same time. Therefore, we are providing, of course, additional tools. So you see here in the back sometimes when an animation in the green part, in the green bar and in the yellow bar, that's, for example, the squelch indication. So every time when there's an incoming radio call from the voice communication system, then it's visually indicated from which airport this incoming radio call is coming. We have also here a special planning tool which enables the air traffic controller to plan the next 15 to 90 minutes, that the workload is always can always be planned for the next few minutes, and that there is really a safe operation possible. But you can imagine that if such a video transmission fails, then of course this is a huge issue for the air traffic controller. And what that means and what consequences it has, I would like to show you a little bit more in detail. So I will tell you what will happen. So in the upper part, which is our very remote location in Iceland, you will see a network brownout. We are not losing the link, just one parameter, the packet loss, is increased slightly so that it affects the video transmission. And first, I will show you what does that mean if you don't have a network management system in place. So basically, this is just connected with a telco-grade network, with the typical telco-grade network management systems, and you will see now the consequences if there is a brownout. So you saw here already a little bit was the image affected, and now it gets worse. So the packet loss gets higher, and now the image freezes, and the air traffic controller is losing the situational awareness completely. And this, of course, has a safety impact. So that is a situation which may never happen in a remote tower environment. Let's have a look on this situation now when we have our net broker in place. So it's exactly the same scenario. The only difference is that we have now a net broker in place. What is happening in the background? The net broker is installed on both sides. So one component is installed at the airport, one component is installed in the remote tower center. Both components are communicating permanently with each other and probing the network permanently. So they are basically actively measuring the network quality on an application level. Not only if the link is here, but they are testing really, they are implementing test packets into the traffic for all applications, so voice communication, data communication, and of course, video communication. And if they detect an issue, then they will now immediately react on this failure. And now the failure is detected, and within 2 seconds, two points happen. So first of all, the main network is switched over to the SATCOM, and because we have only lower bandwidth available at the SATCOM network, also the system reacted in 2 ways. First of all, the upper part of the picture is not transmitted anymore to reduce the bandwidth, and also the quality of the lower part is reduced slightly so that we fit into the available bandwidth at the satellite. And still, all quality is measured. So immediately as the main network comes back, also the system recognizes that automatically and switches back again to the original network. And this, as you have seen, is done totally automated based on parameters, on quality parameters, which the technicians have defined before. And that's the essential part. So basically, the air traffic controller does not have to do anything, so the system reacts on this situation automatically. There is the possibility that you also make a human in the loop, so that the controller, for example, can confirm how the system should react. But basically, it's done automatically. So the operation of the air traffic controller is not impacted. And on the other side, the reaction is clearly defined in advance. So basically, the technicians set exactly the parameters and define if one parameter is not fulfilled anymore by the network, then the system should react in a predefined way. So it's an absolute safe environment where the system can react on this topic. And together with the network management system and our remote tower solution, it's possible to roll out also remote tower solutions at very remote locations where you don't have the perfect network conditions. So either, for example, a typical situation is that you have only one wired line to the airport, like in Akureyri, so in Iceland, that's the case. So here we have only a very limited bandwidth of 20 megabit. And basically we have to realize the backup link via network, via satellite, for example. So that's a typical application to use the network management system. Another is if you don't have bandwidth at all and you need to use a solely satellite connectivity, maybe two ones, so that it's really redundant. And with the new satellite low orbit constellations, that's really possible in a cost-effective way, because in the past, often then the second deal breaker was the costs of the satellite connections with geostationary satellites. So I hope I could give you a small insight how to realize remote tower solutions also for very remote locations with limited bandwidth connectivity. And I think that increases the possibility for all ANSPs in the world, even European ones, a lot, by also thinking now about solutions for remote locations where the network connectivity is not perfect at all. So thank you for your attention, and I may hand back to Haiying.
So thank you very much, Peter and Matthias, for the very interesting presentations. I would now like to proceed to the next session on the UTM. Now, this session will provide insights into the latest developments in the UTM sector. Various aspects will be covered, from commercial demand to the legal framework, with a special focus on the frequencies solution. Now, as a reminder, at the end of this session, we have a question and answer session for all 4 speakers. So if you have any questions, please type them down in the question panel. Our first speaker for this second session is Gunther Graf. He's Vice President, New Business Development and Innovation at Frequentis AG. Gunther leads the departments for corporate research and new business development at Frequentis. Prior to his position, he was Director of ATM Automation, Head of Product Business Area, and Executive Assistant to the CEO, all at Frequentis. So Gunther's mission in the company is to find and develop new ventures and technologies to foster growth within the current business segments of Frequentis. Our second speaker is Mr. Roman Stickler, who is the UTM expert at Frequentis AG. Roman has a sound technical and economic background with degrees in management and business engineering. Starting as a technician, he worked his way up to sales in several high-tech companies. Roman joined Frequentis in 2018 in the AIM area. Recently, he took over business development for unmanned air traffic management. So Gunther, the floor is yours.
Yeah, thank you very much. It is a pleasure also from our side now, hopping over from a remote tower and controlling aircrafts from remote. Another remote challenge is having autonomous drones flying around and thinking about how could they be managed from a traffic management side, because currently there are many drones flying around, but they are not really managed, which is not so much of an issue today. But there are so many great examples of what can be done with these flying computers, that some sort of traffic management is mandatory, and the development of such ecosystem is something that we are following since years, and now it becomes more and more mature. But we are, I think, also not very much there that everything works as in air traffic management, because the challenge is big. We have an air space that is currently not so much managed, except the airspace around the airports, but it needs management in future, and this also needs regulation, law, a lot of new procedures to be set up, and we also need, of course, technology that supports that. And for that, we would like to give you a bit of a glimpse on that. So let's join us here on our thoughts on how to use UTM solutions in that arena. Next slide, please. So what would we cover? So we would like to start with an example where we have deployed it in Europe. In Norway, they have that in operation. So it's quite, I think, should give you a thought on how that works in practice. To do unmanned traffic management out of the tower control, and also in connection with the operator. Then I would like, this will be done by Roman. I would like then to talk a bit on regulation, why it's needed, where do we stand in Europe, what is U-space, a little bit. And then Roman will go on with frequencies and drones. How do we do that? What's the technology behind that? Especially, why do we use the swim concepts for this? And finally, I have picked one use case, especially interesting also, I think, worldwide, is using drones in public safety, and why traffic management will help a lot to save lives there, which is, I think, a great use case. All right, so that would be our program, let's say, for the next 40 minutes, 30-40 minutes. Roman, over to you, and let's look into the Avenir solution.
Thank you, Günther. Ladies and gentlemen, very warm welcome also from my side. 3 years ago, the concept of the Frequentis UTM system was designed, later validated by 2 ANSPs in the course of the GOV1 project, and finally commercially deployed at our first launching customer. And as already said, this is Avenir, and here I would like to give a brief overview about the system. Norway is the first Scandinavian country implementing a nationwide system for the safe integration of unmanned aerial system into traffic control infrastructure. In the course of a Europe-wide tender, the Norwegian air navigation service provider Avenir ANS, together with a subcontractor Altitude Angel, commissioned Frequentis to supply a system for the safe and effective integration of unmanned aircraft systems like UAS. This UTM solution enables Avenir to integrate drones into controlled airspace at 17 airports all around Norway. The future operational spectrum of this solution is very broad. There are search and rescue tasks on the one side, there is the support of blue light organization on the other side, and another use case is, for example, parcel delivery. For our customer Avenir, we provide our comprehensive platform for drone business and UTM as a service, and manage the underlying Microsoft Azure cloud infrastructure, as well as coordinate our delivery and software partners. Our service integration and management approach enables seamless collaboration of cloud and as a service providers in a multi-tier environment. Our platform provides functions and solutions to provide sector pilots, for example, using communities and other business to customer tools for interaction, as well as commercial business. Talking about the products, what do we basically offer and what is deployed there? The products and services provided include an air traffic control specific flight information management system, short FIMS, as a control data exchange platform, a registration system for drones, a web portal for drones, pilots, and a mobile flight planning application. So what motivated Avinor to go with us? There are several reasons. One, of course, is the increasing number, the exponentially increasing number of drones flying in the airspace managed by Avinor. Of course, this increasing number also goes along with rising pressure on also the ATCOs to manage these additional players. Another reason, the safety and security of every participant to any flying object, be it a plane, be it a helicopter, a drone. This is imperative. Hence the need to let the air traffic controller focus on what they do best is, of course, a crucial one. The as a service model, and this is very important as a third reason, enables great flexibility and extremely fast scalability, which would enable Avinor to extend the current solution and apply the already familiar services to other towers or internal customer or local regional services. And the last reason, of course, based on the already implemented projects and ongoing service contracts, Avinor is relying on the Frequentis experience in the ATM domain to build the bridge together into the UTM environment. In the next slide, please go forward. I would like to show you my presentation of a short demonstration of our live system. Should be already visible. Okay, so basically our UTM user interface runs in browser and can also be used on mobile devices. It supports a clear and simple visualization and providers, for example, ATCOs with a common operational picture. I show here how it basically works. There is also the possibility to authorize external and trained third parties to create restrictions, for example, for the airspace. Different map layers shown here, like no drone zone alert message, ground hazard, etc. They can be chosen upfront. Yeah, the ATCO view, what you see here, basically ATCOs, they have an iPad next to them in case that there is any action required for them. They will get the notification on this iPad. So there is no need to look permanently at this iPad. There are already 2 active flight plans, which I created upfront to commercial flight plans. I'll show you later how to create another one. What you see here as well is that there are no upcoming flights planned. There is the time slider function, which gives a great overview, a preview of what is going on in the next 1, 2, 3 hours in the airspace. Now, let me show you, demonstrate following use case. Let's assume there is a crossroad in the middle of the screen right now. And let's assume that there is an accident, car accident, and the police wants in the first step to get an overview about the situation there, how many cars are involved, and so on and so forth. So the policeman will, in the first step, call the ETCO, the very direct way. Also, as mentioned earlier, third-party integration, we can also integrate it, but let's assume here a policeman will call the ETCO, and after the call, the ETCO will immediately take the necessary steps. And I want to show them now here. We do have a temporary no drone zone and the permanent no drone zone. In the first step, the ETCO will create a temporary no-fly zone to avoid any interference with the police drone. Shown here, quite easy to use. Just covering the area, inserting some information, in this case, a temporary no drone zone, reason, safety reason, up to 5,000 feet, and reason accident. So once created, it's immediately in place. And what's very important, both the operators receive immediately a message, please land immediately, air service was closed due to emergency reasons. So at this moment, this air space here over the crossroad is free of any interference. In the next step, the ETCO will go on with creating a flight plan for the policeman. Same procedure, marking the area and then inserting some information done here manually, reason, accident, drone type, drone plane type, it's a commercial one, let's assume, maximum altitude 400 feet. In the next step, the operator will approve the fly strategically and of course also operationally. And now the drone is ready to fly. I also simulate this here. You can see the drone flying here. So basically, the entire system is fully automated. The magic, if you want, so happens behind. Of course, we can show, and you can do also steps manually. What we saw here basically were two domains, both highly complex processes brought together by one simple tool. Thank you very much. And with this, I want to hand back to Günther.
Yeah, thank you, Roman, for the quick overview. I mean, what you can see in such a tool is that there is a technology available to manage drone traffic in cities, but also outside of cities. So you can make sure that the drones land, that drones get the notification, especially that the communication between the ones who supervise the airspace and the ones who want to fly there is guaranteed. Therefore, we also talk a lot with telecommunication companies how to establish this communication, because as you know, in air traffic management, we still rely on VHF to have that, but it won't work that we give every drone pilot a VHF radio in order to communicate orderly with the air traffic controller. And therefore, we are happy that there is a first step for such implementation. However, what is clear, in order to push that forward, there needs to be some sort of regulation and definitions how that would work. And I know also that it is going on worldwide. Some countries are further gone down the road. Some countries are just on the way. And on the other hand, the demand starts up. So next slide, please. And this is just figures from Germany, but I also have seen figures in Asia. The especially professional demand is growing, and I think we are here when we at Canso we are think about supporting professional drone traffic. So there are many drones out there, and many of you most probably also have a toy at home to fly around with drones. These are these private use drones, for example in Germany, which are the majority in number. but the commercial professional drones are also already have a significant number. So only Germany, we have 50,000 drones in 2009 currently, and this will grow further over the next years. And these drones are not just DJI drones. There are many specialized drones for long haul flights and all that stuff coming up. So that's really something that is going into the aviation, and where we have to think about that. And there is also the market growing. These alone figures are for Germany, and you can see also I have the older figures. The initial predictions were lower, which is very unusual for such forecasts. Usually they are a bit higher than the reality shows. So it's really, we can see there is use in applying drones. Next slide, please. So and also I always want to iterate when we talk about traffic management, we very often have these transportation, so urban air mobility examples. But to be honest, I think this will take some time until this will really gets into going, because this is quite complex. All our systems cannot live with the fact that there is no pilot sitting inside the aircraft, and this is actually where all those things want to go. Technically, I think it starts to work. We see all these nice examples. We as Frequentis have flown around a lot in various demonstrations. Roman will talk a bit about that later on, and I think you all have seen those transportation drones. However, when it really comes into let's say usage of drones, there are many more application areas. So asset management, there are inspection cases. There's a lot in agriculture. This is really useful. If you look into that, you really see, hey, this is something. It's not just a little bit. There are thousands of drones flying around, identifying whether crops are good. You also can avoid a lot of usage of chemistry and stuff like that. So especially also the inspection of infrastructure is something that really helps. It's not just saving money, it's really that you can do inspections that were not able before, because the helicopter cannot go that smoothly and film the situation and stuff like that. So there is really commercial scalability needed, and I think we also can enable that by technology. And there are three things that we have to make sure. So there's first of all, we have to give the access to the airspace, which is not that easy in controlled airspace. There needs to be procedures, and we are also in Europe just going on there. Germany, for example, 3 days ago has brought out the legislation. It's still a lot of paperwork related to that. There is, of course, we need to have less administrative effort. There is the one thing to how do I announce a flight? That's the one thing. The other thing is really, okay, I want to do a long haul flight. I want to fly 50 kilometers with my drone because I want to go in a rural area. I want to transport medicine. I want to, let's say, do observation on my railway track, whatever. This is in Europe and formally also around the world quite intensive in terms of paperwork, because you need to do risk analysis, and this risk analysis need to be approved by somebody in the ministry. This guy is not there, so this needs to be automated, and I think this can be done. Yeah, all that you need for that is reliable data without beyond. So you need to know where I'm allowed to fly. Where do I have problems when I fly over? It's also, you need to have ground data. It's not that easy very often. And yeah, these are the challenges that we face, and where the regulation needs to get in. Next slide, please. So what is that in Europe? Just that there is a legal framework coming up by EASA, European Air and Space Agency, where there are now rules set out, and European Commission is mandating that with the 1st of January 2023, that each state needs to provide the reliable data on the ground, because currently in air traffic we didn't care so much about the ground, except it is the airport, of course. But when I fly with a drone, only 100-meter height, about over cities or over whatever area, you need to have reliable data. You don't want to fly over a power plant. You don't want to fly maybe in Europe over kindergartens. You don't want to fly about chemistry, and you don't want to fly over large groups of people. Yeah. Because of the risk associated to that, so you need to have the information, and you would like to know at a certain point of time who is else flying around, so you need to have some services that provide you that. Currently we don't have that. We don't have radar that can identify drones, and we don't have the rules how does a drone communicate its position, and we don't have legislation whether we should believe in that position or not. I know there is a lot of talks also coming from the understandably from the drone industry to say, yeah, drones will just simply deconflict themselves. We see in autonomous driving that's hard, and we have the additional complexity with drones that they just can't stop somewhere. It's a bit more complicated, and you have more dimensions. It's not flat, so not because I don't I want to sell my traffic management systems, or I'm a true believer it will not work without some ground-based observation and rules how drones fly, and some, let's say, separated control. Just don't believe in it, and it's for me very unlikely. However, as I said, there is the commercial demand. There is the demand that we get this kind of scalability, as I said that, and there is not only, let's say, transport and an air traffic management necessary. There is also other authorities that are very interested in that. Fire services, we had that already. Police, we have the law enforcement stuff that is interested in, and then we have also the counter UAV to have in mind. So we want to see whether there is a drone flying around that might be not so friendly. Yeah. And this can only be done if we have an overview about the good ones, and therefore also unmanned traffic management is needed in some regulation. Yeah, that just popping up. Next slide, please. So what's happening in Europe? In Europe, and this is also discussed, I think, worldwide, is the concept of the U-space. So the unmanned space, the space where drones fly around, which is basically currently the unregulated airspace, and especially cities, where I today have a regulated airspace and a no-fly zone. Because usually the airspaces are defined in a way that they go around larger parts of a city, yeah, depending on the country. So therefore, the concept of the U-space came up to say, okay, let's define an airspace where drones, where we have some rules that drones can fly around. Yeah. And we have some service in place, which is the U-space service that can that manages the drone. So and in Europe we have defined and now mandated with the start in 2023 to say, okay, we have to have 4 services that have to be in place for U-space, and several countries will mandate that. So there needs to be a network identification. That is what I said before. A drone needs to identify itself somewhere in the network, and I need to be able to identify the drone. Yeah? And this will be most probably happening via LTE 5G mobile technology. But that's a thing that needs to be set up. There needs to be geo awareness, so all these no-fly zones, conditions, constraints This is happening in Europe quite well. You can download all these apps. The issue is there is not so much dynamic currently in place. You have seen that before in the demo. You have some. It's different. If I have such a non-permanent no-fly zone, I need to have a tooling where I can communicate that to all the drones. Current approach is that the DJI drones have a set of no-fly zones built in, but that approach doesn't work for such emergency cases as we have shown here in our tooling, and this will be also this is also mandated in Europe. Then there is the topic of flight authorization in EU space. So you have then a service provider that authorizes the flight. Yeah? Similar to ATM, but it should become a automatic approval, except for exceptions. This is from the service provider, like here in Avinor. It's also the ANSP. Theoretically, could also not be the ANSP, but I think it's useful that the ANSPs have that additional service, and where you get the flight authorization. And finally, you have the traffic information. Traffic information means that this is also currently not mandated. In Europe, we started that. How do I know where else a drone is flying around in my airspace? Currently, there is no tooling for that, and with such tools as we have shown to you, we can manage this problem. And then, in addition, there will be weather information and conformance monitoring, but that are optional services. Let's see, they make a lot of sense, especially conformance monitoring, making sure that the drone has really followed the defined path that needs to be done, but that will happen also. Right. That was my quick glimpse in what happens in Europe around drones and use space and regulation. I hope you got a bit of an insight, and I would like to hand over to Roman and look a bit into our solution and technology, how that looks like.
Thank you very much. So, next slide, please. Well, there is the highly standardized ATM market, as you can see here on the left side. There is a steadily increasing number of new entrants with new needs and rising number of operations on the right side. The pace gets faster and the level of connectivity increases. The need for advanced automation is evident as these new entrants require a bunch of new services. Next slide, please. These factors have been taken into account while designing the Frequentis UTM system. It ensures a seamless information exchange between all the stakeholders, bearing in mind that we have to connect more and smaller systems than we did so far. Existing procedures like data quality and review processes are even more important to build the bridge between the manned and unmanned aviation. For example, the Frequentis UTM system handles AIM data fully swim compliant. At the same time, it provides this information to new airspace users in adequate formats based on swim principles. Next slide, please. This brings me to a real-life demo, a large-scale demonstration. I already mentioned it at the very beginning of my part, the GOV project. This is our joint undertaking research program, GOV USpace, where the integration of unmanned traffic management and air traffic management systems has been demonstrated. We were part of it. USpace services in 7 advanced trials with 11 unmanned and manned aircraft operations have been tested successfully. So different operations like urban drone fleet operations in controlled airspaces, one operation. Another one, police intervention, cooperation with search and rescue forces in general air traffic, maritime traffic surveillance combined with border guards, drone fleet operations in Tallinn, inspection flights, and also drone taxi. All of these operation services have been tested in real. That's an amazing progress. Next slide, please. Information management assures the provision of commonly understood quality information delivered to the right people at the right time. So most of you might remember this ICAO swim principle. ICAO set the rules and we realize them by connecting stakeholders, system-wide information management. This is our key part. Aircraft, ground control services, ground services, and new capabilities like counter-UAS sensors are all considered in our design. The information exchange services, together with the common information services, facilitate information exchange between the stakeholder. Realizing the single source of truth is enabled by this flexible yet strong architecture. Federating services where possible, ensuring consistency where necessary. This allows for a resilient ecosystem. Interoperability, connectivity, and automation are key factors in terms of building this ecosystem. Finally, thinking of big additional racks at your premises when looking at this architecture, not necessarily. As already mentioned in the Avinor case, the cloud-based approach of Frequentis UTM system allows for scalable, flexible, and dynamic business operation. Operators like ATM or UTM operators are in the center of this ecosystem. Frequentis UTM system enables them to perform safe and secure flights. Next slide, please. This brings me to the UTM ATM data exchange platform, the mosaics. The key functionalities of the solution are first, the conversion of proprietary data formats into industry standards to be accessible for all stakeholders of the ecosystem shown here. Second, of course, the provision of a single source of truth for common operational picture and joint operations command. And third, enabling further business by monetizing data for third-party application and services. It's also shown here on this slide. The main target is to provide services based on service-oriented architecture, data validation, and transformation capabilities, comprehensive support for all relevant standards and interfaces for weather, flight plans, surveillance, and airspace data. This architecture and solution design finally leads to a quality operational data, considering the importance to guarantee the accuracy, integrity, consistency, and timeliness of such data when used by the consumer. Next slide, please. This brings me to my last slide at this point, the UAS utilization in safety critical environments. So what you see here is basically where UAS is contributing. And as you can see, UAS contributes significantly to the successful completion of the safety tasks, be it like here, public safety, core target group, blue lights, police, fire, brigade, rescue, or others like airport, rail, and streets, or power, water, waste stations. So in all of these safety critical sectors, UAS can contribute very, very big points. With this, I hand over to Günther.
Yeah, thank you very much. So finally, I have the example, and I will make it short. In public safety, I think we touched it already today, how drones can help. And next slide, please. There is really the possibility to save a lot of time to be on spot. Yeah, and there have been research programs here where we also have been part of, where we say, okay, what is the advantage for that? Yeah, and how can we really identify an accident? How can we be faster in helping? And it's really you can really see that the average response time for public safety accidents, for example, can be dramatically reduced. And this is also one of the reasons why I fight so much for, okay, let's bring drones in a professional environment to be used, and therefore we need the traffic management. Next slide. And this is something where really I want to wrap up what we discussed now with this use case. As we said before, we have an accident, we have a fire here that starts. So the officer has to get the information call out, and give the information to the supervisory center or to the control room to say, okay, what's next? Yeah, and with the drone, please click next. Once again, yeah, we are here in the trial. Really, we can we can send the mission. We can send the drone for a mission and the required capabilities. Next click, please. And for that, with what we have discussed today, having a capability that does traffic management really enables that. Next click, please. So we can easily request that mission. Yeah? Instead of sending a car there, we request the drone mission and send it out. Yeah? As we saw before, also what Roman showed, we can then communicate to everybody who might fly a drone, who is interested in that airspace in a city. We can plan the mission and publish it quickly within seconds, yeah? And make it available, make a drone or no-fly zone available. Next click, please. We can request the approval for that flight if it's maybe near an airport or so on, and get immediately the approval for that flight out of the air traffic control tower because it's nearby or it's within the control zone. Yeah? And this approval can be provided by a click. So it really takes only a second from fireman identifies a fire, calls into the control center decides, okay, send out the drone, and everybody is informed about that drone flight. Yeah. And we can execute the mission within seconds or minutes, send the drone there, and within minutes I'm at the spot where I need to have the observation. A drone flies there, and yeah, that is really the advantage why I need that technology in between that also Roman described before, right? And the sensor data can be pulled back, so video observation and everything is fine. The data can be given back to the observation, and the next steps can be decided within minutes. I think that's now the last click. Yes, and of course, with Frequentis Mosaic Swim, that can be handled. Technology is there. Next slide. Finish. All right, summary. We want to enable to fly. We have the technology ready. We know regulation is coming up. And I think it's really now about time to focus on that growth, and also for all aviation authority to prepare for introducing the technology. So if you want to have an in-depth demonstration or discussion, looking forward to do that. And with that, thank you very much for staying with us, and I hope we have some question now. Thank you very much.
Well, thank you very much, Gunther and Roman as well. We've come to the end of the second session. I would like to invite questions from the audience. Can all the speakers please turn on your camera? Peter and Roman. turn on your camera, please. Okay, the first question, actually the first two questions I think are related, so I will pose it to Gunther and Roman on the UTM. When you mentioned the EDCO will create the zone, I presume this is not necessarily the on-duty controller, but a staff member taking care of the special flight office. And I think a related question is, has any study been completed on the UTM manipulation by a controller? How labor intensive is it, and at what commercial benefit?
Okay, the first part I can answer that way. So no, must not be the one EDCO on duty. So staff member can also carry out this one. As I said during the demonstration, this entire procedure is automated, can be automated. So it was just to show how it would work. It can work. I showed it in the system, but basically it can be fully automated. This was the first part. Second part was about the research paper. Can you please repeat the question?
Okay, has any study been completed on the UTM manipulation by the controller? How labor intensive is it, and at what commercial benefit?
I mean, what I can say from Avinor is that they said that it's much less work now for the air traffic controller with that system than before, because they had so many people calling in and trying to fly around, and so many exceptions also happened without these procedures, that it is less work now for the air traffic controller than before.
Thanks very much. Next question is for the remote tower. I think it's for Peter or for Matthias. For remote tower, does a controller need specialized license in order to work under remote tower environment? And if yes, what sort of specialized training is provided or required?
Yeah, the question is quite easy to answer. So basically, of course, the air traffic controller needs a technical training on the system, but this is not very long, because our system is especially optimized for a very simple user interface, a very intuitive user interface. So basically, after a first training of 1 hour, the air traffic controller knows all the features and then is able to handle the system properly. And beside this, there is no extra training or licensing needed. So basically, the endorsement for the specific airport is exactly the same. What you have to consider in a multi-remote tower environment is that, of course, the air traffic controller needs to have the endorsement for all the airports he wants to control, and this defines the typical limit of 3 airports, because to keep 3 endorsements or more than 3 endorsements, that's basically almost impossible in most of the countries. So there is a physical limit of 3 airports, which can be for which the air traffic controller can be certified.
Thank you. One question for Matthias is, can we combine different VSAT solutions within one network, or is there interoperability between the LEO and GEO solutions?
I mean, yes, you can combine them. That means you can run them in parallel. Over the air, that means over the satellites, they are not, let's say, compatible because of the different protocols they are using over the satellite links. But again, you can use them in parallel, for example, as a primary and a secondary, and then introduce all the functionalities as mentioned earlier with the net broker for traffic flow, service management, KPIs, and so forth. And that's, of course, a possibility to do that, yes.
Next question is on UTM. Can UTM concept and implementation be done globally? Or the concept can be global, but implementation models can only be regional? What is your view? I'm of the view that the UTM to be effective must consider local challenges and circumstances, which cannot be global but regional at best. Gunther or Roman, would you like to answer this?
Yeah, I can answer. I mean, there should be ideally global rules, especially when it comes also to drones, because drones are also manufactured somewhere and they also need to connect to data and so on. But I mean, it's like with the air traffic management or the aviation itself, there needs to be rules. There needs to be rules. How that can be managed, yeah? And these need to be implemented by each ministry. There need to be law for that, so this will be regional. But also what comes to when it comes to UTM and drones, the flights are predominantly between 1 or 2 countries and not more. Yeah, so therefore there need to be worldwide regulation. And I think also CANSO is taking on that. There is a strategy. I'm also a part of the strategy group, and to set up a strategy for worldwide same rules to be applied. And then there will be some local flavors as always. But yeah, I think I'm the same opinion as the person that posted the question.
Okay, thank you. I think it's a follow-up question to Peter's answer. How many hours of training per controller have been provided? Only 1 hour? Did I get you correctly?
No, but basically, a typical remote tower training course for the system is about 3 days. But after 1 hour, the air traffic controller is familiar with all the systems, and then of course then the training starts. So typical is between 3 and 5 days.
Okay, I think this one is probably Matthias can answer this. How much bandwidth is needed for remote tower minimum requirement?
I think I will answer the questions. That depends a little bit on the system design. As you have seen before in the Akureyri setup, this is a very small setup with only 5 fixed cameras and 1 pan-tilt zoom camera. And of course, dependent on the system complexity, the bandwidth is dependent. But what we have learned is that you have a realistic chance to start with a bandwidth of about 20 megabits. So in Iceland, we don't have more. I think we have even a little bit less. We have 16, what I have in mind. So this is a setup where a small remote tower system still can support and help you. And of course, the larger the system is and the more cameras you're using within the system, of course, the more bandwidth you need.
Okay, we have time for one last question, and this question is for Matthias. I think it's referring to, is your network system modular, and can we implement certain elements such as measuring functionalities?
Yes, this is what I mentioned earlier is, so what I try to introduce is the full-blown network management system, which incorporates monitoring and measurement functionalities. And of course, they can be implemented on a service-by-service basis. That means if we have, for example, for the remote digital tower, we want to monitor only let's say the video quality, then that's possible. If we have air-ground communication we want to monitor, then we can do that as well. So you can really build up application by application up to the full-blown network management system. Yeah.
Okay. One question just came in, so I think I'll just allow for this last question. For the remote tower locations, how many movements per day do they service?
That's totally different. So we have in Akureyri, there are about 2,000 movements per year, so very low traffic. But if you have a look at our system in Vienna, for example, that's 160,000 movements per year. So basically, a remote tower is adaptable for all kind of use cases, from very small airports to even the largest hub airports. And maybe you have heard about that London City, for example, recently went to remote tower operations. So London City has about 80,000 movements and is now entirely remotely controlled. But there are also remote tower systems in Changi Airport, in Hong Kong, which have even higher traffic numbers. So basically, remote tower systems in the meanwhile is applicable to all kind of airports, from the smallest one to even the largest hub airports.
Okay, so time's up. I will have to close this question and answer session. I will thank all the speakers for your time. I will now hand the microphone to Gunther to give some concluding remarks. Gunther.
Thank you very much. And yeah, thank you all for listening in. Yeah, to wrap up, I think there is a lot of change coming up in the aviation. There is the remote tower that really gives also the possibility to provide services in regions that maybe are not reachable today or not serviced professionally. On the one hand, and also with UTM, all these additional flying objects can be serviced professionally. Maybe in future we also have remote tower centers that also do UTM for U-Space. Let's see what the future brings. Looking forward to that. Looking forward also with our team to help and assist you. Here you see again the contacts of the speakers. Yeah, would be glad if you contact us if you have additional questions. Reach out to your local sales, to our local sales offices in your region, and we are looking forward also in future to be on site and on spot again. Digital is great, digital is the new normal, but physical will be greater in future. Looking forward to that, and thank you very much for this talk.
So thank you very much, Gunther. As what Gunther has said, that should you have more questions, please feel free to contact the panelists. I would now like to conclude by acknowledging Frequentis for its sponsorship of this year's CANSO Asia Pacific Conference, and to thank all our presenters as well as my CANSO events colleagues for their technical support. And last but not least, thank you for your active participation. Goodbye.
Thank you, Haiyang. And thank you to all our speakers today. And a big thank you to everyone for participating and attending today's webinar. Haiyang, it's a pleasure to share your final webinar with you today. You will be missed. Now, to all our attendees, once you leave today's webinar, you will receive a survey, and we would appreciate if you would complete that and provide your feedback. So on behalf of Frequentis and CANSO, thank you for joining us today and enjoy the rest of your day.